Okay, one interesting application of vectors is in motion diagrams. So when we have motion diagrams, right, so like this one here, right, so this is a motion diagram. So then we would like to, we draw vectors that represents the velocity between the different points in the motion diagram. How do we calculate these vectors? Well, there is a way to calculate this vector, and it's using the vector displacement. So if you take the vector displacement and you divide that by the time that it took for that displacement to happen, you get the vector velocity. So let's look at a simple example here. For instance, you have a plane that is 100 kilometers from Denver, east of Denver, and then after an hour, you find the plane 200 kilometers north of Denver. So what is the velocity of the plane? So we need to calculate the displacement, we need to calculate this vector, and then finally calculate the velocity. The vector displacement would have a magnitude and some direction, which is given by an angle, right? So that's how we're going to represent the vector in this problem. So let's find the magnitude. If you look at this, this is a right triangle. So we can use Pythagoras to find the length of this side here, and that would be the magnitude of your vector. So if we do that, so the length of the vector, the magnitude of the displacement vector is 100 kilometers square times 200 kilometers square, which is Pythagoras, right? This side square plus this side square, so it's 100 square plus 200 square. So that'll be the length of your vector. So that's what we have here. When we do that math, we get this number, which is 224. The other thing that we need to find is an angle to represent the direction. So if we look at this figure here, a good angle to represent the direction is this guy here. So we need to calculate that angle. So going back to our trigonometry, then we know that the angle is given by this side here, 200, right? So this side divided by this side, the tangent of that. So the tangent of 200 divided by 100, that gives you the angle. So if we do that, so we get the tangent, the inverse tangent of 200 divided by 100, and that gives you 63.4 meters, 0.4 degrees. So now we have the magnitude and we have the direction of the vector. So we can write the vector as 224 kilometers and 63.4 north of west. That is the direction and the magnitude. So now what we wanted initially was the velocity, so we take 224 meters and divide that by delta t, which is an hour, and you get 224 kilometers per hour, and the direction is the same, right? The direction is not going to change, so that is your vector velocity. So another thing that we can do is from vector velocities, from initial and final velocities, final and initial, like here we can find the acceleration, right? Acceleration, remember, is delta v over delta t. So how do we do that? Well, we just need to add and subtract vectors, right? So here we have 3 points. We have this guy here, and this guy here, and then the velocity, the initial velocity is this vector, and the final velocity is that vector. How do we find the acceleration? Well, we take the final, remember, acceleration is equal to final velocity minus initial velocity divided by delta t. So we take the final velocity, which is this vector. Then we are going to subtract the initial velocity, so it's the opposite of this vector here. So we're going to subtract that, so that is that vector here. So this is your delta v. So now delta v over delta t that is your vector acceleration, so your vector acceleration would be a vector pointing in that direction. Quick question, a particle undergoes an acceleration while moving from point A1 to point 2, from here to here. Which choices shows the velocity vector 2? So the particle moved from 1 to 2, and then this is the acceleration. So find the right vector 2. Just take a minute to answer this question. Okay. So now the acceleration, remember, acceleration vector is equal to delta V divided by delta T, which is equal to final minus initial divided by delta T. Final is 2 and initial is 1, so this would be velocity at 2 minus velocity at 1 divided by delta T. So this is a velocity at 2, this is from 1 to 2, right? So that is the acceleration. So which vector you would need to get this acceleration vector? That is a question that we need to answer. So the answer would be 2, right? Because this is the acceleration vector, which is delta V over delta T, right? And so if you look at this, so you get this, A is equal to delta V over delta T. So A times delta T, this is a vector times a scalar, is equal to V2 minus V1. This is delta V. So then we want to find V1, so we're gonna write that, sorry, V2. So we're going to write that V2 is equal to V1 plus A delta T. So then our vector V2 would be a vector that goes from here to here in this direction, so it's got to be that vector.